Temper is one of the most interesting programming languages I've seen recently, and its idea is very simple. It's not designed for applications, but for libraries almost exclusively, and it's designed from the ground up for transpilation between as many languages as possible. While they do include an interpreter and a REPL for testing, Temper's real goal is to compile the same code to as many different languages as possible for use in libraries. Imagine you just invented a new file format and it's really great, but nobody can use it if they can't parse it. That's where Temper would come in. You can write your parser in Temper and compile it to Rust, Python, Java, C#, Lua, and more. While I do like the idea, I think there are some really serious flaws, so in this video I plan to get into exactly why I don't think Temper is going to work out, while still acknowledging what it gets right. Before we get into anything, I do need to say that Temper is a very small project. There's around maybe 5 videos I've seen on it, and the language only has about 5 contributors. I know it's somewhat likely that my video becomes one of the more popular videos covering Temper, so it's worth being very clear. I don't think anybody working on Temper is doing anything bad, and I don't mean any harm to anyone who works on Temper or uses it. While I certainly think the language has its flaws, I'm trying to be reasonable and honest about it. It's been a bit hard to research for this video, since the language is so niche. I've done my best to verify everything that I'm saying, but there may still be mistakes. Check the pinned comment for more information. Additionally, Temper is still in active development. It's only been open source for a couple of months, and it's changing all the time. If this video gets more eyes on Temper and it becomes someone's new favorite language, despite my feelings about it, that's still a success in my books. I'm just trying to get more information out there. Temper is a language that transpiles. This means that rather than the Temper compiler lowering your source code into an intermediate format, or to machine code, it translates your source code into equivalent source code in other languages. Currently, Temper can do this for Java, JavaScript, C#, Python, Lua, and Rust, with the C++ backend on the way soon. The idea here is super simple. Let's revisit that file format example from the beginning. Let's say you just invented Markdown, a simple text-based document format that turns into HTML. People love Markdown, since now they can write their emails and blogs in easy, simple, plain text with a couple of symbols here and there, and let your program do the heavy lifting to turn that text into the messy, hard-ish to read HTML that's actually being used. Then, someone gets an idea. What if we went the other way? They create a program that lets users visually create these documents, changing header size, adding links, bold, italic, strike through, and it exports as a Markdown file they can use anywhere. The issue is that when you created your Markdown program, you wrote it in Perl. That's fine for people using your application directly. They don't care what it's written in, they just need an executable. But when someone else wants to build with your code, that's when the issues arise. It's not impossible. They could write their app in Perl, but it's not really meant for desktop apps. They could embed a Perl interpreter inside their process and load up your source code if your license allows that. Really though, it'd be nice to just be able to use your library like any other library. Just call the functions and be done with it. So eventually, enough people have this problem and someone bites the bullet. Your Markdown compiler is nice, but we need something that everyone can use. We need something in C. C is the lingua franca of the computing world. If a library wants to be usable by everyone, it needs to be in C. That's fine, it works and people are happy, at least for a while, but eventually, people want this on the web. Wouldn't it be nice if someone could input Markdown on a web page and compile it directly on that same page and preview it right there too? Unfortunately, C can't run on the web, at least not yet. WASM isn't until 2017, so you need another port. Now there's the original Markdown compiler, the C Markdown compiler, and the JavaScript Markdown compiler. Wouldn't it be nice if the original was just written in something a little more portable? That story wasn't very far removed from reality. The original Markdown compiler is written in Perl, then CommonMark came around to specify Markdown and make a C implementation of the compiler. Then they came along with a JavaScript version too, and even a Java version. If the original creator had used Temper, had it existed at the time, this headache could have been largely avoided. Instead, the Markdown compiler would be written once and transpiled to Java, JavaScript, and whatever other languages you need. At least, that's the idea. There are a lot of flaws with it, unfortunately, so let's get started. Here I have some Java code and some Python code. The two look equivalent, but they don't run the same. In Java, the order of the keys is effectively random since it's based on the hash. Python, however, guarantees that the order that you iterate over the items in the dictionary is the same as the order you inserted them. C# has something similar, but when you remove an entry, the next may fill in the holes left by the previous. Temper has to figure out what to do here, and there's not many options. They could make it undefined behavior, or at least implementation defined, but that's a bit of a hack. It may work for these niche cases, but there's so many subtle differences between languages, Temper has to pick one. In Temper, hash maps maintain insertion order, like Python. There's a lot of features like this. For example, Temper is heavily built around assuming automatic memory management. For most of Temper's targets, that's fine, since they have GC. However, they also compile to Rust. Because of that, Temper wraps basically every non-trivial value in an arc. Here's a little example of what that looks like. As you can see, the input string is turned into an arc, cloned, formatted, and then turned into another arc and returned. Another example is even basic integer math. This add function is about as basic as it can get. Ideally, it would compile to just one CPU instruction. However, different languages define these things in different ways. In Java, we can get away with basic addition, but JS requires ORing with 0. Python requires clamping and some wrapping operations, as does Lua. And Rust has used the wrapping add method. These cases are all small on their own, but they lead to Temper producing pretty weird code in a lot of languages, since most behavior is defined by Temper rather than the target. This also leads me on to my next point, generated code. The actual generated code that gets spit out by Temper is less than ideal, to say the least. You already saw a bit of this, particularly with Rust, but here's a bigger example. First of all, the code comes out unformatted for the most part. There's some new lines and some indentation, but I'll go ahead and clean this up myself. Now you can see a bit of what we're working with. First off, the variable names are all jumbled up. Anything public has an all-right name, but local variables and parameters are pretty strange. You can also see that our methods and our fields are separated out for some reason, and the struct itself is actually just holding an arc of our read-write lock of our fields. Then we also wind up with a builder struct that holds the exact same data as our actual struct, which is automatically generated for every constructor in Rust. Looking at the real code, our operations get pretty confusing. We're unwrapping on every single field access because of the arc and the lock, and our new method makes a handful of useless variables. Last thing in here, you'll notice, we can't actually touch our fields directly. Instead, everything is forced through these getters and setters. There's an argument that this code doesn't matter. After all, it's not public-facing, right? If you want to read the source, you read the Temper source, and the Temper language is a very conducive language to documentation. It even supports literate programming, which allows you to use markdown files as the source code, where the Temper compiler works on embedded snippets within that file. This basically makes comment first class and code second class. Still, I would argue that it's not okay to produce code this messy. Reading source is always better than reading documentation, and when my go-to definition keybind sends me to this stuff, I'm more likely to drop the library entirely than try to figure out what on earth is actually going on. Plus, actually working with this generated code isn't pretty either, since Temper makes its own guarantees about behavior, often different from the ones made by the target language, so you wind up with several places where they don't mesh super well. If I want to use a map in Temper, that's easy. I use the built-in map type, or the map builder type if I want something mutable. What if I want the user of my library to interface with that hash map? Well, then the user also has to use Temper's map and map builder. Of course, this isn't necessarily hard. It's all Temper, so it's all cross-compiled where it's needed. But it is different. Most of these languages have their own maps, dictionaries, or tables, so using Tempers isn't an automatic thing. Temper is a little lucky here. Most languages Temper targets support interfaces, and the ones that don't happen to still handle maps pretty much exactly how Temper needs them. Even still, if you come across some Java codebase that expects the hash map class instead of the map interface, you're going to need to take your Temper map and turn it into a Java hash map, which is going to be extra annoying if you ever need to go back into Temper for the map after. This leads to the sort of function coloring where anything that needs to touch Temper winds up dealing with the Temper API, and this leads to extra memory allocations to convert to and from the right types at every call boundary, or using these temper types all over your codebase, which effectively defeats the purpose of using temper at all, since it's no better than FFI. So far, most of what we've been looking at is the output. To me, that's what really matters. Syntax is always secondary to real results, but it's worth taking a closer look at how temper itself is actually designed. It's loosely object-oriented, but doesn't have inheritance, and it has a very simplified notion of constructors, and it's immutable by default. Some of these choices just reflect the preferences of its creators, but you can also see how temper has had to conform to its targets. The extremely minimal constructors are a direct consequence of this. For example, temper used to have more complex constructors, arbitrary code that you could run, but to ease code generation and make them more reasonable to work with, temper switched to using a closer syntax to a data class or a record. Similarly, they generate a builder pattern for every constructor in languages that don't have things like keyword arguments, which I mentioned in Rust. At the same time, temper has a huge number of features that restrict its targets, its object-oriented programming being a huge one. Sure, you could compile OOP code down to C just fine, but can you make it actually have a nice API from C? There's no notion of method or private field, so the best you can get away with are simple prefixes and things. That's not to mention the reference counting, which would have to be done entirely manually in C. Furthermore, temper has closures and even a full async await API. These features are the final nail in the coffin for a huge number of languages, including the vast majority of ones I work with, including Zig, C3, C, and Odin. When you want to compile to so many targets, you really have to try and figure out which features you want, because every feature will close at least one language off. Technically, a lot of these more complex features are implemented as a form of macro, so the temper frontend translates it into something simpler. Still, that doesn't change the fact that it's complex behavior, and you still need something to implement it in C. Additionally, temper is leaning quite heavily towards expression-based semantics, with things like do blocks that effectively work as an inline evaluated function, and implicit returns based on the final expression in a function. While some languages do work this way, most of temper's targets don't. Instead, these semantics have to get translated, which is just one more layer of messy code gen. Do, specifically, is exactly that, an inline evaluated function. Maybe the temper backend can handle inlining these trivial cases, but in general, a language that leans on callbacks and anonymous functions just won't translate well to a large number of other languages. Temper also has pattern matching, both for standard values and for types. They also have Kotlin's trailing block syntax, which allows you to write code like this. Temper also has exceptions, but not really. As far as I can tell, there's only one type that can ever be thrown, and it can't be done directly. The only type you can throw is bubble, and the only way to throw is with the bubble function. That said, the type checker doesn't seem to care what type I put after throws. Maybe this is a type checker bug, maybe I'm missing something. There is no try keyword, however, catching is done via or else. Temper is explicit about nullability, so you need to append a question mark to any types that permit a null value. Temper also has generator functions, which may yield to pause their execution and be resumed later, and their async await API, which is built on top of these. Temper uses a ton of macros. They allow the front end to pile on more and more complexity without burdening the back end, but arguably, these are just encouraging bloat. There's also no way to define your own macros, so they may as well be regular language features. So, temper has to conform to this minimal intersection of its targets, outputs code that's hard to read, and is restrictive enough that a large number of languages couldn't be supported anyways. What's the argument for why you should use temper? From everything I can see, and people I've talked to about temper, there are a few different use cases. One, people who don't like to code, but can. Sometimes you just need to make a thing, but you'd really rather not. Maybe you're a manager, a designer, whatever, and you need to mock up something quick and simple to integrate into a few parts of the codebase. It can be quick and dirty, purely used internally, and not something that needs to be amazing. You can just write it in temper, compile it down to whatever handful of languages this codebase uses, and slot the implementations in where you need them. 2. You actually like temper. Temper isn't a bad language at all. It has plenty of features that people are into. Even though temper isn't designed for application development, there's no reason you couldn't treat temper as the primary development language, and then just compile it to JavaScript for a web build, compile it to Rust for a native build, etc. 3. You're working across multiple languages in one project. Maybe you have a Rust backend and a JavaScript frontend. If you define all of your types in temper, you can guarantee that they have similar behaviors and APIs across both languages. I think these are all somewhat reasonable use cases for temper, but you'll notice none of them actually mention libraries. I still, really, do not think you should use temper to create libraries that you use across languages, because the internals get so jumbled up, and because temper semantics don't always map super cleanly onto target languages. You're pretty much out of luck if you want to inspect the internals of the target language. Temper tries to make up for this by making itself hyper-documentable, but I don't think that makes up for this at all. Another thing you might think is that temper would be good for cross-language communication. If you already have Java and Rust in the same project, maybe you can use temper to allow them to communicate. That's not how it works though. Since temper exclusively cross-compiles, you'll wind up with a Rust version and a Java version of your temper code, with no way to connect them. If that's what you're after, then I guess we should address the elephant in the room. Way back at the start of the video, I talked about Markdown. Specifically, I mentioned that Common Mark formed and created a C Markdown parser that's incredibly widely used. I mostly brushed this off at the time since I wanted to get into temper, but let's go back. Why would a C implementation be better than a Perl implementation? Basically, every language in common use today has some way to interact with C. Rust, Lua, Python, Java, and C# all have this behavior. You can write your library in C, and then call into that library like you would any other library. Because of this, a lot of languages are able to make their own functions look and work like C's, which means your Python code can call my Odin code, because we're both speaking C. This is super powerful, and it makes C the best option for libraries that are trying to be usable everywhere. Plus, we have WebAssembly now, which means even JS can get in on the fun. Just compile your C into WebAssembly, load it from JavaScript, and you can call those functions too. So, what does temper provide that makes it stand out? Well, there's a few things. For one, C is a very simple language. Personally, I like that, and I do a lot of programming in C, but not everyone feels the same. Additionally, it means that going from a higher level, more abstract language down to C often requires compromises. This usually shows up in the form of generic type erasure, user data pointers, and much simpler types. Since temper has first-class generics, closures, and a more powerful type system, this sort of thing isn't necessary. Temper just spits out the right type definitions, and they can be used directly in language. In reality, what temper does and what C do aren't fully overlapped. C is about one library that can be used everywhere, and temper is about making the same library several times over, automatically, focusing on writing the code like you want, and letting the compiler figure out how to make that work. They both have compromises, but they shine most in different areas. For example, your C library uses user data pointers to make it compatible everywhere, and callbacks to make things work asynchronously. Temper just has closures and async functions, so your temper code reads really simply. Unfortunately, that dumps the burden onto the users of the libraries instead. I don't know how temper would react if you asked for a closure in a language without them. Maybe they'll automatically add a user data pointer to every function? It's possible since each language gets its own version of the library, but that sounds a bit messy, especially since temper doesn't actually distinguish capturing and non-capturing functions. I mentioned this a bit earlier, but I want to call out a specific thing about temper. It requires automatic memory management in some form. Garbage collection is most common, but Rust, alongside their upcoming C++ backend, both require reference counting instead. The issue here is, of course, cycles. Currently, there's simply no solution here, but that's not the plan forever. Supposedly, temper devs plan to disallow all reference cycles at a language level. While this would solve the problem, it's hardly a nice solution. Just because we're supporting Rust and C++, doubly linked lists are fully impossible to create? I'm sure they'll implement some workarounds for this, but it just strikes me as an odd choice for a language that wants to be flexible and work anywhere. Geez, this was a long video, huh? I didn't plan to make it quite so big, but I guess I had a lot to say. Temper is a super interesting language, and I'll certainly be keeping an eye on it. If you think I'm totally wrong and a huge idiot and Temper sounds amazing, feel free to check it out. The link to their GitHub and website are in the description below. You can contact me on Discord or by Twitter DM if you want to reach out, and I'll see you next time.